Chris Williams with Intellisense Systems, and today I'm talking to Ryan Guerrero, our Flood Sensors Business Development Manager. Over the course of the past few years, Intellisense has been working with the Department of Homeland Security and the City of Charlotte, North Carolina, to implement a low-cost flood sensor network. Ryan is going to share some of the detail of that project with us today.
Thanks, Chris.
Let's start with a little bit of background on Charlotte, Mecklenburg.
Thanks, Chris. Yeah, first off, I should clarify, when we talk about Charlotte, Mecklenburg, we're talking about Mecklenburg County, North Carolina. It's home to the city of Charlotte, which is one of the fastest growing cities in the United States. They added nearly 800,000 residents in the last decade, and now it's the 15th biggest city in the United States. They're supported by Charlotte-Mecklenburg Stormwater Services, which is a joint municipal and county stormwater utility. That means they provide flood response for over 1 million people. They manage to run off from rainfall, restore floodplains, and protect quality of surface water across the county. So when we say Charlotte-Mecklenburg, that's what we're talking about. It's the specific stormwater and flood response utility here in the United States.
What were the challenges they were facing?
In terms of challenges, Charlotte-Mecklenburg was addressing the same challenges that all emergency management agencies face. They wanted to, 1, reduce fatalities, 2, lessen property damage, and 3, support community resilience to flood warning events or flooding events. Now, accomplishing those goals is not easy. Charlotte-Mecklenburg was in a unique situation. They have a lot of lowlands, wetland areas in the county, nearly 300 miles of streams. They have 2,800 structures in floodplain areas, which means a lot of people and property are susceptible to flooding. They are also vulnerable to hurricanes each year. In fact, 2018, Hurricane Florence dumped over 30 inches of rain in Mecklenburg County in just 1 week. It was the rainiest hurricane in the state's history. So with those 3 things, that's made it some of the most challenging areas to address for flood warning events. But another challenge they're facing outside of rainfall and geography is that they didn't feel like they had enough data to accurately assess flood risk. They had a limited data set from a sparse number of stations. And in order to make decisions they were comfortable with, they needed far more data from a much larger network of flood sensors. Now, because of those conditions, they are seen as an industry leader in flood warning systems. If your system can work there, it can work anywhere. So that's why they're always seeking and receiving new innovative solutions in flood monitoring.
And what were they using prior to this solution?
They were using traditional gauge sites like those used by the U.S. Geological Survey, or USGS. They are customized, highly accurate gauges that provide water level and inundation data that Charlotte-Mecklenburg was looking for. However, they're pretty large gauges and very expensive. They even require a crew of 3 or 4 people to install 1 gauge over a single day. They were also customized with the components from different manufacturers. Now, if an assembly line was disrupted, they may or may not be able to get the gauge components and parts that they needed. As a result, they only had 50 of these gauge sites set up across the county. Charlotte-Mecklenburg decided that they needed at least 100 flood sensors to make right response to flood events, so that's why they sought for a new solution.
Interesting. Okay, so how did Charlotte-Mecklenburg go about finding a new solution?
Charlotte-Mecklenburg found a new solution with funding from the United States Department of Homeland Security's Science and Technology Directorate, or DHS-S&T. Now, the U.S. government is heavily investing in flood response technology because flood have become the biggest natural disaster in the U.S. Actually, it's bigger in damages than hurricanes, tornadoes, earthquakes. It causes about $8.2 million in damage and even around 100 deaths per year in the United States. So they're getting more and more invested in the mitigation flood risk. Now, as I mentioned earlier, being in such a flood-prone area does have its benefits. Charlotte-Mecklenburg was seen as the ideal place for this test of the new solutions because of all the conditions and challenges they face. If a new solution could work there, again, it could work anywhere. So the Department of Homeland Security created a program called Flood Apex to begin developing this emergent flood risk technology. Charlotte-Mecklenburg's Stormwater Services quickly partnered with them, and Mecklenburg County became the premier test site. From there, they started to solicit proposals to develop low-cost autonomous flood sensors through the Small Business Innovative Research Program, or SBIR for short.
So what is needed in IoT flood inundation systems?
First off, the flood sensors needed to be low cost. This would enable stormwater services to increase their sensor network to the amount of data they needed to make better decisions. One requirement for being considered low cost, though, was also limiting the maintenance cost through limiting the amount of on-site visits. This would be achieved by a variety of different features, but it would start off by simply adding the use of two-way communications, because if you can retrieve data from the sensor, it would be best if we could also send those commands remotely, and that would save us a lot of time and money. Second was compatibility. These sensors need to be software agnostic. In fact, Charlotte-Mecklenburg used two different platforms to track their flood data: the Flood Information and Notification Systems, or also known as FINS, and another third-party software platform. So the new systems needed to be compatible with multiple existing software platforms. Third was reliability. These flood sensors must work autonomously through long-term deployments. They also have to be modular, field replaceable, report the system health, and monitor its status. So that was another requirement. Fourth, and probably most important, was accuracy. The data from these low-cost flood sensors must be comparable to traditional stream gauges. Finally, the last requirement was durability. The sensors were needed to withstand many natural and man-made hazards, including heavy rainfall, heavy winds, wide range of temperatures, and so those are the 5 primary requirements.
Interesting, okay. So tell us about the solution used in Charlotte-Mecklenburg.
So to address being low cost, we started with a single, self-contained, rugged communications unit that could attach multiple sensors. The communication unit is small and easily field replaceable. It also is very discreet to determine from vandalism, which was an issue recognized by Charlotte-Mecklenburg over the course of their testing. It was also capable of two-way communication, again, for that less on-site visits. This saved a lot of cost. For our next cost-saving strategy, we decided to design a pressure transducer to operate with less maintenance. We found that one of the main reasons for pressure transducers requiring maintenance was they needed to replace their desiccant. So we designed a pressure transducer with no desiccant. The solution was small and discreet. It was less susceptible, again, to vandalism, but also less susceptible to getting dragged out of its mounting position by debris in fast-moving streams. We also made installations very cost-effective. The communications unit could be installed on a fence post, pole, or bridge, so we could use a pre-existing structure even if we needed to mount these units. We also simplified the pressure transducer installation process. You simply plug the sensor into the unit, turn the unit on to auto-calibrate, and confirm that the data is coming in at 0.0, and then install the pressure transducer in the water. This process takes about 15 minutes, and now you have a crew of 1 to 2 team members installing 3 or 4 sensors a day, rather than the 3 to 4 teammates installing just 1 gauge a day, again, saving a lot of money. To address compatibility with multiple third-party platforms, we designed the communications unit with a direct-to-IP approach. That means it uses TCP/IP socket protocols, which is used by almost every internet-based data server out there. This code and packet structure can be integrated into almost any existing server network. And the hardware was an open architecture. So if there's any enhancements or new software platforms, our system can support it. After testing Charlotte-Mecklenburg, we found that our system achieved 90% reliability. This met the standards for Charlotte-Mecklenburg. We made a number of enhancements and changes to improve the reliability, and we'll talk about that in a minute. Next was accuracy. As I mentioned, the data from the low-cost sensors had to be comparable to the traditional stream gauges. To test this, Charlotte-Mecklenburg co-located our low-cost flood sensors alongside with their legacy stream gauges to compare their accuracy. After about 12 months of testing, our sensors were accurate, within 0.04 feet, like 0.48 inches or 12 millimeters, to that of the USGS gauges. This was well within Mecklenburg's accuracy requirements. Finally, for durability, our systems could withstand a year-long deployment. In all of our, over 90 communication units, only 15 of them needed to be replaced or repaired over the course of that year. And that was because mainly vandalism issues or issues of the installation location. We have made some improvements there also to bolster the durability of these units.
Okay, Ryan. So how hard was the solution to install?
Yeah, so the system is very easy to install. Like I said, the communications unit can be mounted to any existing structure, like a bridge, or if there's a fence post, or you can really install a simple T-post very quickly and attach it to that. And you can install it pretty far in lengthwise. We can go up to 90 meters in difference between the sensor and the main unit. We also made sure the pressure transducer and camera sensor were easy to install also through that auto calibration. The installers can check right then and there in only 15 minutes if they're getting the right data, and then quickly secure the pressure transducer in the water and proceed with their day.
So Ryan, what kind of future enhancements are in the works, and what kind of installation difficulties have you seen?
Yeah, going through the different phases of the project, we were able to capitalize on a few lessons learned. The first thing that we learned was we needed a rain gauge and a non-contact water level sensor. When we first started this product, we had a pressure transducer, and then we added a camera, which Charlotte-Mecklenburg really appreciated, to get eyes on the ground on the site and not have to make that costly trip. However, we still needed a rain gauge to account for precipitation, so we added that to our system. We also added water level radar for a non-contact sensing solution. Sometimes debris continues to dislodge a pressure transducer in fast moving streams, so we wanted to integrate a water level radar sensor to accommodate for those situations. The communication unit has 4 ports, and at least 3 of those sensors can be attached to the unit at any given time. Throughout testing, we also found that we needed to ruggedize some areas of the system. The first was the cellular antenna. We initially used a flexible antenna that could be pointed to better gain a greater signal strength, but it really wasn't rugged enough. And for the weather for Charlotte-Mecklenburg in those situations, we had to come up with a new antenna, and we did. It's much more robust, and we also created a new bracket for the pressure transducer that was more rugged and could withstand a little more of that debris hitting it in those faster streams. We also changed the power up and power down process in our cellular modems to minimize any potential premature failures we could have. And those are 3 of the enhancements we've made over our testing, and I'm sure we'll be able to make more features and accessories available to customers as their needs come in the future.
where else is this solution being used, Ryan?
This flood sensing network is being used in other parts of North Carolina, as well as many other states, including places like Kentucky, Tennessee, Virginia, Utah, and in our home state of California. It has been implemented in parts of Canada as well. These are all different climates and weather patterns that we have to face and accommodate for, and systems working well in all of them.
Okay. Well, Ryan, you talked about a lot of US installation locations, but are these sensors available to the rest of the world?
Yes, these sensors are currently being used in other parts of the world. We are currently testing units with international SIM cards, but they are available to be used in many parts of the world.
So if somebody wanted to purchase these, where can they find that information?
The best way to find more information in our flood sensor is through our website, intellisense.com. That's where you can find the case study details of our testing process. You can see any data sheets you need on our products, and it's where you can also request a quote or ask any questions you might have. You can also email me directly. My email is rguerrero@intellisense.com. I'd be happy to answer any questions you have or talk about your specific needs.
Perfect. Ryan, I really appreciate your time, and thank you for being here to answer all of my questions. Thank you very much.
Yeah, thanks, Chris. This has been a great opportunity. Please reach out. Happy to answer any questions about flood warning.
Excellent. Thank you very much.